Thanks to Magellan TV for sponsoring today's video. You may never have believed it would actually happen, but the James Webb Space Telescope has launched, and no, its rocket didn't explode in a fireball on the way up. But that doesn't mean we are all good to go just yet. The telescope has some risky months ahead of it. Why is that? Well, James Webb has to make it to the Earth's L2 Lagrange point, all the while performing the delicate operation of unfolding itself before it can unfold our understanding of the universe. I'm Alex McColgan and you're watching Astrum. And in this video I want to go through the deployment process of the James Webb Space Telescope and go into the details of how James Webb goes from being in the rocket all the way until its final science-ready state. I hope by the end of this video I've earned your like and subscription. The Ariane 5 rocket is what engineers planned the James Webb Space Telescope around, the rocket being one of the European Space Agency's big contributions to the mission. The Ariane 5 launches by first igniting the liquid fuel main stage and then the supplementary solid fuel boosters. Ariane 5 has two of these boosters, weighing 277 tons each, and those combined with the liquid fuel stage can take the rocket to the edge of space by themselves. Solid fuel is often used initially, as while it can't be controlled so easily, it is a cheaper fuel type and good for that brute force initial liftoff. Once the boosters are expended at about 75 kilometers up, they are jettisoned from the main stage, leaving just the liquid fuel engine burning. Liquid fuel is useful because it can be throttled if needs be. About a minute later, the rocket is beyond the Kármán line of 100 kilometers, and the fairings surrounding James Webb can be safely jettisoned. At this altitude there is virtually no atmosphere anymore, so the telescope no longer needs the fairings protection. About 8.5 minutes after liftoff, the main liquid fuel stage is finally expended, and it too separates from the upper stage. The main stage, like the fairings and the boosters before it, will all end up in the ocean. With all that weight gone, the upper stage ignites and gives Webb the boost it needs to get to the Earth's L2 point. Initially, the altitude doesn't increase, in fact it even dips, as this part of the process is about building speed, and gravity helps with that a bit. However, this is already a potentially risky phase of the trip, as the sun's rays are directly interacting with the telescope here. Although it is folded up, the Sunshield is not deployed, and sunlight can reach Webb's delicate instruments here, warming them up. Until the Sunshield fully deploys, it's not totally protected. In order to distribute heat as evenly as possible, and to keep the really delicate parts in shadow, this upper stage rotates back and forth by 30 degrees, like a baby in a cradle. Once in position, the flight trajectory takes it up into space. Its speed still increases even as it combats Earth's gravity, due in part to the fact that the rocket is getting lighter with every passing second as the fuel is burning. At 25 minutes in, the upper stage cuts off and there is a 2-minute coasting phase. Here the rocket rotates around in order to perform a collision avoidance maneuver. Webb then separates from the upper stage, and from then it is all by itself. It is very interesting to me that this view of it leaving the upper stage is the last view we will ever have of the telescope itself. And seeing as this has already happened, here's a beautiful shot of the very first thing Webb did, which is its thrusters firing and then its solar panels deploying, which was actually performed slightly earlier than expected. During separation, usually some rotation is introduced on the payload, but this time there was hardly any rotation at all, and the thrusters had to do very little to keep James Webb from rotating too much, meaning it was safe to deploy the solar panels almost immediately. From here, James Webb provides its own thrust. The cradling maneuver continues using these thrusters, regulating the telescope's temperature. To protect the mirrors as much as possible, these thrusters are only located on the sun-facing side of the spacecraft. A day and a half after launch, the high-gain antenna is deployed, and James Webb passes the moon's orbit. At this point, James Webb has already slowed considerably, as it's basically going directly against the gravity of Earth. Just short of 3 days into the mission, the Sunshield pallets begin to deploy. This is a very slow process to ensure nothing breaks, and so Webb doesn't start spinning around uncontrollably from the pallet's movement. Almost 5 days into the mission, the tower separating the telescope and the Sunshield extends. This is the aft momentum flap. This is a pretty clever fuel-saving idea. The flap will offset the tiny amount of solar pressure pushing on the Sunshield's membrane, meaning Webb doesn't need to use as much fuel to combat this pressure and stay aligned. Still on day 5, the Sunshield protectors will unroll and open. Now for the really delicate operation. The center booms will extend, and with them, it will gently pull the Sunshield membrane open. If you recall, this was one of the tests that failed back in 2018, as the membrane ripped in deployment. These membranes are thinner than a human hair, and once fully extended, are the size of a tennis court. When stretched, these membranes will be tensioned, finally fully protecting James Webb from the sun's harsh rays. The sun-facing side of the telescope will get very hot, almost to a boiling temperature, whereas the side with all the instruments will be kept to a cool -230 degrees Celsius thanks to this Sunshield. 10 days after launch, the instruments are cooling down by passively radiating their heat into space. From here, the secondary mirror deploys, locking in place. Next is the aft radiator, a passive cooling system that will radiate the instrument's own heat into space. This is crucial to maintain cool temperatures. On day 12, the side mirror wings will rotate and latch into place. 15 days in, the telescope is fully deployed, and it's simply a matter of waiting for the telescope to reach the L2 point and cool into its final cryogenic temperature state. The last operation to complete before James Webb will be operational is the alignment of the primary mirror segments. Each can be adjusted to within nanometer precision, allowing the light collected by Webb to be turned into crystal clear images. After 29 days, there is one final correction using the onboard thrusters to put Webb into its halo orbit around the Earth's L2 point. From this orbital point, the bright Sun, Earth and Moon will always be behind the Sunshield, meaning the brightest thing in Webb's view will only ever be Jupiter. Roughly 160 days after launch, the instruments will have cooled down enough to be operational, and any adjustments that need to have been made will have already been completed. From here on out, the James Webb Space Telescope will be collecting science and unfolding the universe. If you like space telescopes, there's a lot more than just Hubble and James Webb out there. We've had telescopes in space for decades, from Kepler to Spitzer to Gaia and more. If you want to know more about some of these other ones, there's an interesting documentary on Magellan TV called Eyes to the Heavens, where they explain more about some of these missions. Gaia in particular is fascinating to me, as it's a sky survey mission, and it has catalogued billions of stars and their motion in the sky over the years. Magellan TV has a special offer on right now, where you can buy a year's worth of membership and get another annual membership for free, potentially a good gift for someone you know that enjoys science and history documentaries. If you want to check out Eyes to the Heavens and Magellan TV's offer, check my link in the description below. I highly recommend it. Thanks for watching. Check out my other James Webb video here if you want to know about what the mission hopes to accomplish. A big thanks to my patrons and members for supporting the channel. If you want to support too, check the links in the description below. All the best, and see you next time.